Okay, so as we saw in the last lesson, we have to solve a system of equations, right? We used substitution in order to find our S and our T. So what I'm going to show you in 9.2 is another way to solve a system of equations, okay? Now, when you only have two equations, it's not so bad to solve two equations. But when you have 3 or 4 or 5, it can become quite tedious. And so I'm going to show you guys matrices today and how to use matrices to solve a linear system. Okay, so that's what we're going to talk about in this lesson. So not so much about any intersections. We're still only going to be talking about the intersections that we learned in 9.1 and between a line and a plane and between two lines. But I'm going to talk to you about solving how to solve systems of equations using a matrix. Okay, so we saw this just in the last lesson. If we have two lines, we know that, or actually even if we just have two lines in two space, right? So then we know that we can have one solution, parallel lines, no solution, or coincident lines, meaning one on top of the other, infinite number of solutions. If we are in three space, we have that added solution where the two lines are skew. Okay, so no point of intersection, but not because they're parallel, they are skew. Okay. Okay, so how do we solve a linear system using matrices? So it's called Gaussian elimination. So system of equations can be solved more easily using the Gauss-Jordan method. A matrix is a simplified version of a system of equations that omits variables and uses only the coefficients to solve. So if you notice, here I have x plus 2y equals -7, and over here in my matrix, I have 1, 2, and -7. So you can see that the 1 represents the coefficient of x, the 2 represents the coefficient of y, and then it equals -7. And then I do the same thing for my second equation. So I have 2, -2, 10. So again, the 2 represents the coefficient of x, the -2 represents the coefficient of y, and it equals 10. Okay, so this is how we set up a matrix. And so now what are we going to do with this? How do we solve it? Well, we want to try and solve for x, y, and z, right? So if this represents my x, then I want there only to be one solution. So I want to solve for only 1x equals something. And then y is my second column. And so I want to be able to solve for y equals something. Okay, so what do we want to do? We want to try to make it look like this. Because now this is telling me what x equals. X will equal whatever this number is. And this is telling me what y will equal. Y will equal the number over there. Okay? If you have an x, a y, and a z, it's the same. We just have another column. Okay? So notice I have a 1 in my first row in the where my x coefficients go. It tells me what x will equal. And then a 1 where the y is, because it will tell me what y equals, and a 1 where the z is, it will tell me what z equals. So that's the goal. That's what we want to do. So how do we do that? What are some strategies? Well, these are just equations. So we can take a row and we can multiply it by any non-zero constant. We're not going to multiply it by 0 because then we're just going to get 0, 0, 0, right? But you can multiply a row by anything, just like you could a regular equation. Another thing that you can do is you can interchange the rows that the equations are in. Like I didn't have to put 1, 2, -7 as my first row. I could have put 2, -2, 10 as my first row. It's what it's going to come down to is what makes your life easiest in solving. Okay. I could multiply one whole row by some coefficient, by some number, right? Any number. And then I can subtract it or add it to another row, right? Basically elimination in order to solve. Okay, so let's see how we could do that. So here I have 1, 2, -7, 2, -2, 10. So what I've done here is I've taken row 1 and I've added it to row 2. And the whole reason that I did that was so that I would get a 0 here. Now notice I have 3, 0, 3. This is very good because what I can do in my next step is divide that whole first row by 3. And then I can see that x equals 1. Okay, now my second row, I've gone ahead and I've divided by 2. Why do you guys think I divided by 2 there? Why is it a good idea to divide by 2?
So we get a 1.
Yeah, we want ones, right? In the end, we want to get ones. So now I've got a 1 there, and now I just have to figure out how I could make this a 0, okay, if possible. And I would go from there, okay? So basically, we want to end up with 1, 0, and a number, 0, 1, and a number in 2 space. If it's, or I should say, if it's 2 equations. Here I have 3 equations, and I'm in 3 space, right? So 1, 0, 0, 0, 1, 0, 0, 0, 1. Are there any questions? Okay. So let's take a look at an example. So first of all, how would I put this into a matrix? How many rows will I have?
2 rows.
You're gonna have 2 rows. How many columns will I have?
3.
Yep. So I'm gonna have 1, -2, 8, 3, 5, -9. Okay, now the goal is I want 1, 0 in a number, and then 0, 1 in a number. And what we usually do, okay, there are some exceptions, but what we normally do is work from column to column. Okay, and there's a reason for that, and you're going to see as we start working why that makes the most sense. So I already have 1 for my x coefficient there, which is really good. So instead of trying to make the -2 0, I'm going to go and work with the 3, and I'm going to make that 3 a 0. Okay, and like I said, it's going to make a lot of sense why we might do that. So I'm not going to touch this row for now because I have that 1 there. I want to now make that 3 a 0. So how could I make that 3 a 0? What could I do to get a 0 here? Working with the 2 equations. So what I could do, and I'll just do it on the side here. We're not going to do this. You're not going to show me this on a test. You're not going to show me this work. You're just going to show me what's in the matrix. But what I could do is take that top row and multiply it by 3. And if I multiply that top row by 3, I would have that, right? So I could take that top row and multiply it by 3. And then I can subtract it. Do you see that? So now I can take my bottom row and subtract the first row. So I'm going to show what I'm doing here on the side, and I'm going to show that I'm going to take row 2 and I'm going to subtract 3 times row 1. And so what happens? I have 3 minus 3, which is 0. I have 5 minus -6, or 5 plus 6, which is 11. And then I have -9 minus 24, which is minus 33. First column, done. Now I go to the second column. What's my goal for the second column? What do I need?
The 11 to be a 1.
I need that, good. I need the 11 to be a 1. And what about the -2? What do I need the -2 to be?
0.
Yeah, I need it to be a 0. So do you see anything that I might be able to do? So if I want to make that 11 a 1, let's start there. What can I do?
Divided by 11.
Yeah, good. You can take row 3 and just divide it by 11, right? And so I get it.
Okay. Why is it row 3? Is it row 2 or?
I'm sorry, say that again. Oh, I wrote 3. I'm sorry.
Okay.
I don't know, because I was thinking of 33 and then number 3. Okay, thank you. So I'm taking row 2 and I'm dividing by 11 to give me 0, 1, and -3. Now, and I can leave this alone, or I could do 2 steps in 1. Okay, but I'm just going to leave this alone for now. Okay, so I'm good. Now I need to make that -2 a 0. So what should I do next? I want to make that -2 a 0. What should I do?
Well, 1 plus 2 times row 2.
Excellent. So if I multiply that row 2 by 2, I'm going to have 0, 2, negative 6. And now what I can do is add them. Do you see that? Okay, so if I add them, I have 1 plus 0, which is very good because that didn't affect my 1. And then I have negative 2 plus 2, which is 0. That's the whole reason we did this. And then I have 8 plus negative 6, or 8 minus 6. And so now you can see from looking at this that x equals 2 and y equals negative 3. We found the point of intersection. Now, some of you might say, but Miss, this is harder. This is more confusing. You're right. If you're dealing with two equations, you're just going to use substitution elimination. No big deal, right? But if you're dealing with many equations, this is worth the hassle. Okay? It is less tedious than having to deal with multiple equations. Okay? So, yeah, question?
Yes, so like what you're trying to do here, you make like one of the rows like based on 0 and 1, and then with that row you make the other one equal to 0 and 1, right? Is that what
Yeah,
you're trying
because
to do? Okay.
yeah, because think of it like this is my x row. So this is going to tell me what x is equal. So if I have a number here, well, that's not going to help me. I need x equals, right? Otherwise, I'm going to have an x plus y. And then
Yes.
here, I want this to tell me what y is going to equal. So I need this to be 0 so that it tells me just what y is equal to. Do you see that?
Yeah.
Okay. Do you guys want to try another example?
Sure.
Okay, let's do this one, okay?
Yeah.
So now, in my
Oh, sorry,
matrix,
Brian.
sorry,
it's fine.
question?
Wait, you go ahead. That's fine.
No, tell
Miss,
me, what's up?
like, what if there's no solution?
Yeah, there might be. So you tell me, what do you think is going to happen if there's no solution? Go back to grade 10 and what we just talked about in the last lesson. What happens when there's no solution?
It won't be possible.
You're going to get a false statement.
Okay.
So you're going to get something like, right, like you're going to get something like 0y equals a number. Well, that's not true. And so therefore, there's no solution.
Okay, thank you, Miss.
Okay, so what do you think is going to happen if there's infinite number of solutions?
0,
When
0
there's-
equals
that
0.
means that- yes, exactly, because then z could be anything, right? And so yes, exactly. Okay, so it's basically the same that we just saw. It's just happening in the form of a matrix. Okay, so here I have -2, -6, -1. And here I have a fraction. Okay, so the first thing I think I want to do always is get rid of the fraction. That's the first thing I'm going to do here. So in order to get rid of that fraction, I have to multiply everything by 2. And I'm just going to leave the first row. I don't want to start working with too many rows because I don't want to confuse you. And you always have to write what you did. So I have to show that I took row 2 and multiplied it by 2. Okay, so now I told you to work column by column. So if I'm working column by column, what should be the next thing that I should do? What's my goal? What do I want to get next? So we look at column, the first column. I've got a -2 and a 3. Sorry?
2 plus 1.
Yeah, good. We're going to try to make this a 1. That's where I'm going to go to next. Okay, we're going to go column by column. So I want to make that -2 a 1. And you're absolutely right, Brian. We're going to do that by adding the first equation to the second. And so I have -2 plus 3. And then I have -6 plus 10. And then I have 1 plus 2 is 3. Oh, hold on a second here. It's negative. And be careful of little errors like that because, oh boy, when you make that kind of a mistake, it's quite a mess to go and fix it after. So -1 plus 2 is what we want. All right, and then I still have 3, 10, 2 again. Okay. All right, and now next, what I want to do is what? Where would I go to next? And maybe I'll write little notes here. So we wanted to make -2 to 1. So next, what do I want to do next?
Make the 4 0.
But we're going to go column by column.
Make the 10 1.
Careful. So if I were to, let me just entertain your idea. So let's say that I go ahead and I make this a 0, okay? Then I have to make this a 0. And so when I start adding, subtracting, doing all these functions, so when I start to make this a 0, it's going to affect my 1. It's going to mess me up. And that's why I want to make this a 0 first. So now when I start adding and subtracting equations, it doesn't touch my 1. Does that make sense? So once you get a 1, get everything underneath it to be 0. So then whenever you deal with that equation again, you don't have to worry about it being changed. You guys follow? So what I want to do next is make that 3 a 0. Do you follow? Do you guys understand why I'm saying that? Okay, so to make 3 a 0, what am I going to do?
2 minus 3, 1.
Yes. I'm going to take equation 2, and I'm going to subtract 3 times equation 1 to give me 3 minus 3, which is 0. And it's going to give me 10 minus 12, which is -2. And it's going to give me 2 minus 3, which is -1. And I'll leave this alone. What should I do next? What do I want to do next? Remember, column by column. Sorry, nice and loud.
Make the 4 a 0.
You can make the 4 a 0. We generally get our 1s first, right?
Okay.
Get our 1s first. So I want to make that -2 into a 1. So how can I do that?
Divide by -2.
Sorry, say that again.
Divide by -2.
Good. We're going to take that third row and we're going to divide it by -2 to make it a 1. Excellent. Okay. And now, Brian, now we're going to make that 4 a 0. Okay. What should I do next? And it's okay that I have a fraction in my answer. It just means that my coordinate is a fraction, right? That's okay. So to make that 4 a 0, what am I going to do to row 1? No one knows?
1 minus, sorry.
Good. And so here I have 1 subtract 0, doesn't affect anything, right? Nice. And then I have 4 minus 4, which is 0 because 1 times 4 is 4. And then here I'm going to have 1 minus 2, right? When I multiply by 4. And so this is saying that, therefore, my solution is -1/2.
Yes.
Yeah.
What would have happened if we have like multiplied like, you know, -2 by like 2, and then we add the equation 2 and 1 together and then make the 4 0? Like, what would have happened? Because like, would that like make it
Nothing.
like nothing?
Nothing. No, as long as you get this result, you're going to get the right answer. As long as you're using, as long as you don't make a mistake, right? But as long as you get this matrix, you're going to get the right answer. Doesn't matter what steps you use. You might not use the same sequence of steps that I use, and that's okay.
Mm-hmm. Okay.
Right?
Yeah, yeah.
Yep. There's, you know, not just one way to do it. There is always an easier way, that's for sure. There is an easier way. But there's not just one way. Okay, so let's try this guy now. We're gonna try another one. Okay, so we already have a 1 there, that's good. So now, based on what I said to you guys, what should I do next? What's my next step? What do I want to do? Yes. Excellent, thank you. So we're going to take equation 2, and we're going to subtract it by 3 times 1. And what happens when I do that?
Your whole bottom row is 0.
Which in one way is kind of good because it makes your life easy, that's for sure. So what is this telling me? It's telling me that 0 times x plus 0 times y equals 0, right? Or essentially 0 equals 0, which is true. It's true, 0 equals 0. So what's it telling me?
Infinite solutions.
Yeah, infinite number of solutions. X and Y can be anything. Okay,
So
infinite. Yeah.
if any of the rows are 0, 0, and 0, it means that infinite number of solutions.
It depends with how many equations you're dealing. Okay, so yes, in this case, when you have 2 equations, yes. Once you have 3 equations, then we have to look at different options.
Okay.
Okay,
Thank you, Liz.
because, yeah, no problem. Because if you start dealing now with 3 lines, well then, just because 2 might be coincident doesn't mean that all of them are, right?
Okay.
Yeah. Okay, let's look at D. All right, so here I have 1, -7, 8, and here I have -4, 28, 0. And I already have the 1 there, so what should I do first? I want to make that
-4 is
yeah.
0.
Good, perfect. And so how would I make that -4, 0? What am I going to do to that row 2?
2 plus 4, 1.
And what happens here? So -4 plus 4 is 0. That's what we wanted. And then I have 28 plus -28, or 28 minus 28. And then I have 0 plus 32. So I get this. And this is showing me that 0x plus 0y equals 32. Is that ever possible?
No.
Never. False statement. So what is this telling me?
No solutions.
No solution. Yeah, so no solution. Okay. Good.
Yes. On your notes. Oh, never mind, miss. Never mind. Okay.
You good? We're all good?
Yeah.
Okay. So this method can easily be extended to solve 3 equations in 3 unknowns. So let's do this one. And this is when this starts to become really useful because like I said, substitution elimination with 2 equations is not bad. It's not even really that bad with 3, but you know, it's a little tedious. We saw that in our last example. Sorry, our last lesson, not last example. All right, so how do we always start? Well, we start by making that first column, first row there. We want that to be 0. So I want to make that 5 a 0. So there's so many different things I can do. Try to choose for me the easiest or what you think might be the easiest. What do you guys think? want to make that 5 a 0. So what I'm going to do, and you don't have to do this, but what I'm going to do is I'm going to bring that -1, -1, -4, and 10. I'm going to bring that to the first row. So then I already have a 1 there as my x. Now, did I have to do that? You don't have to do that. You can go ahead and just make 5 0, but that's what I'm going to choose to do. So I'm going to switch rows 1 and 2. Oops, and I don't write it here. I write it in the next one. And yes, you have to write this on the side, guys. Whatever I'm writing in blue here, or these little directions on the side, you have to show me. So I'm going to write it where I do it. And so now I've switched 2 and 1. And yes, you could also divide this in one step. For the sake of the lesson, I won't, but you could. And then here. Mhm. Okay. All right, so now you're going to start seeing me do more than one thing at a time. So yes, we can take that first row and divide it by -1, right? And notice it becomes row 1 now, right? We don't have to keep referencing it as row 2. It became row 1 now. So I'm going to do that. Oh, what's wrong? Uh-oh. Hold on 1 second, guys, please. Hold on. Actually, you guys keep working on it. Keep working on this and see where you end up with this, okay? And then we'll take it up together. How's everyone doing with that question? Yep. Are you actually doing it? Be honest. Are you guys actually doing it, or are you just waiting for me?
Kind of.
What kinds of what? Which one? Doing it or waiting for me? Because if you're, I'm not gonna just waste time. If you're just waiting for me to do it, we'll do it together.
Waiting.
You're waiting. Okay, let's do it. Okay, so I have 1, 1, 4, -10. So next, according to what I told you, what should I do at this point? What do I want to go to next?
Make the 5 a 0.
0.
Yeah, I want to make the 5 a 0, and then I want to make the 3 a 0, right? We're going to work row by row. So find your 1 and then make your zeros. Okay, so if I want to make that 5 a 0, what can I do? How about if I add 5 times row 1? What do you guys think? Is that cool?
Yeah.
Okay, so what am I going to get?
0,
Yep.
-8, -19, 45. Wait, no. 57.
Good. Excellent. Okay. And now let's go ahead and do the other one as well. So I'm also going to take row 3 now, which is 3. And this time, I'm not going to multiply row 1 by 5, but I'm going to multiply it by 3. And so go ahead and do that above, and what do we get? So I hope you guys notice, I'm not using the row 1 here, 1, 1, 4, negative 10. I'm using the negative 1, negative 1, negative 4, 10, because it always refers to the rows as they were one above, right? Oh, something happened here. Did I always just write make 0? That said something different before, did it not? That was weird. Okay, so what do I get here? 0, and then I'm going to have 2 minus 3, and then I'm going to have 2 minus 12, yes, and then I'm going to have 0 plus 30. Okay. What should I do next? What do you guys think? What should I do next?
Make the -8 a 1.
Okay, I can make the -8 a 1. Do you see a 1 in that, another 1 in that second column? Look at row 3. Do you see that there's already a 1 there, but it's negative?
Yes.
So what if I swap it? What if I put that in place? So what if I switch them? So what if I say, let's take this row 3 and multiply it? Okay, hold on, let me just write the first row first. So let's take that row 3 and let's multiply it by -1, and it's going to become my new row 2. And then row 2 will come down here, and I think I'm also going to do negative row 2. Oops, what am I doing? And so I'm going to have 8, 19, -57. How's that? So now what do I do next? What's my next goal? What do I want to do next? I want to make 4 a 0. Yes, is that what I want to do next? What do I want to do next?
Make the 1 a 0.
Yeah, you want to make the 8 a 0, right? Now, or the 1 is 0, yes, in my second column, and also the 8 to 0. Okay, so remember column by column. So we want to worry about that, this 1 and this 8. Good, excellent. So let's do it all both together here. So if I want to make that first row 1, first row, second column 1, a 0, what should I do? What should I do to row 1?
Subtract row 2.
Yeah, I'm going to subtract row 2. And I want you to notice, because I have all zeros below that 1 is not going to be affected, which is really good, right? Otherwise, it's a pain in the butt. So 1 take away 1 is 0. And now I have 4 take away 10. And then here I'm going to have -10 minus -30. Okay, my middle row is good for now. We're going to leave it alone. And then my last row. How am I going to make that last row? That 8 a 0. What am I
Minus
going to
8,
do?
minus 8 times the second row.
Sure. And I like that you chose the second row. Why didn't you choose the first row?
Because like it subtracts more of the third column.
Oh, okay. Interesting. Okay. What's
Also
another
because
reason?
the first
So-
variable
yeah.
has to stay there.
You got it. The first variable has to stay 0, right? So I have to work with that row too. Okay, good. Excellent. Okay, so go ahead and subtract these. I know I'm going to get 0, 0. And what else do I get? So what do I get here? Anyone? No one?
Minus 61 and then 183.
Perfect. Good.
By the way, for the
Yeah.
second row, shouldn't that be minus 30 instead of minus 36?
Yeah, I can't read my own writing. Yes, it is. Thank you. There we go. Let me fix it here. There we go. Okay, hold on one second, guys. Keep working on this. Okay, so you guys still waiting for me, or did you guys actually go ahead?
What I had.
Did you? Excellent. Okay, good. So what did you do next? So we're looking pretty good here. I've got 1, 0, 0. I've got 0, 1, 0. So what do I want to do next?
Divide row 3 by -61.
Excellent. So we're going to make that a 1. Excellent. Remember, get your ones first, then clean up the rest of the column. So we're taking row 3 and we're going to divide by -61. And what's 183 divided by -61?
-3.
And so we can see from here that Z is equal to -3. Excellent. Good. And then I have this. Okay. And now it doesn't matter which one you tackle next. What do you want to do next? I have to make my last column have 2 zeros, right? For rows 1 and 2. So how would I make that -6 a 0? What should I do?
1 plus 6, 3.
Good. And I'm kind of forced to work with 3, right? Because remember, we don't want to mess up that middle 0. Okay, so 1 plus 6 times 3. And that's going to give me 1, 0, 0. And what? What's my last coordinate?
2.
Good. Excellent. Okay. And then my second row, I have to make that 10 a 0. So again, I'm going to work with the third row, right? I'm going to do row 2, take away 10 times row 3. And so I'm going to get 0, 1, 0. And what do I end up with here? You get 0. And so this is showing me that this is the point of intersection. Cool? So that means that these 3 lines will intersect at this one point. Are there any questions? Pretty good. So matrices can be tedious, and the reason that they can be is because if you make a mistake and you don't find it, you can get the wrong answer, right? So you have to be careful. Or if you make a mistake and then you don't realize where you made the mistake, you got to find it. So just be very, very careful when you're doing them, okay? But they are very useful when you're dealing with many equations, okay? Are there any questions? Okay, so you guys can get started on your homework.